Hi, I'm Randall Heyman, a mathematics academic. Welcome to my YouTube Corona Help playlists, now completely ad-free. Here I do quick turnaround videos to help educators and students. So if you'd like me to make a video for you or your students at either primary, secondary or university level, then comment me below any of my videos or drop me an email. Someone in the US has asked me about this. Is an ideal an additive subgroup of its parent ring? So I'm going to have a look at that. Hope you're going as well as you can given the circumstances today whilst you're watching this. Okay, so the first thing I want to talk about is what does it mean, an additive subgroup? Let's just explore that for a sec. So let's call the ring, we'll call ring R plus multiplication. Those are the two binary operations. The ideal is, let's call it I plus times. Okay, so this is really saying is the additive subgroup. So is I just with the plus, which we'll regard as a group, is this a subgroup of its parent ring? So it's really saying, is it a subgroup of R just with the positive? That's what it means by subgroup of its parent ring. Okay, so let's just, I'm not sure if I've gone through subgroups. So just to go back to that, sorry, the additive means that we're just looking at the additive operation. We're ignoring the multiplicative operation. So subgroup, what does that mean? So I suppose A is a subgroup of a group B if A is a subset of B and A is a group itself. Okay, so this bit here, this A is a subset of B. Well, here we have, well, if you look at the definition that I gave of, what was it the definition of? Yeah, definition of a ring. So if you look at my definition of a ring, we said that, so it said that if we have R plus times like this ring, well, that tells us that R plus is a commutative, abelian group, we called it. Group. So that you can get from the definition of the ring if you go back over my videos. So if I just push this up a bit, so if it's a group, well then that would mean that the ideal is a subset, in this case equal to, I suppose, subset of a group, or of the group R plus. So that's good. Now the problem is it's got to be here. This is saying it's got to be a group. In other words, we have to show that I is a group itself. So to do that, you would look at the definition that I had on my videos for a group, and they were closure under addition. We also had the existence of a 0. We had the existence of a negative. And we had associativity. Okay, so now the next thing so this is what we'd have to show for the ideal. Now, let's now talk about the ideal. So if you look at my definition for ideals, you'll see I said there was this concept of it being a non-empty subset. And then we said A minus B is an element of the ideal. Sorry. We said that for all AB that are elements of the ideal, we must have that A minus B is an element of the ideal. And we had also A is the ideal in the ideal, R is in the ring. Well, that must imply that A times R is an element of the ideal. So if we go over to here, well, this associativity we can prove. Where can we prove that? Well, it comes from here because it's a subset of the group. So if it's a subset of that group, well, the group's got associativity. This group's got associativity. Remember what associativity is. I'll just write it up here. A plus B plus C equals A plus B plus C. So the order of addition is important. Is not important. That's what associativity means. So we get that from, because it's a subset of the group. Now these ones here, we get them from, actually this one. So I think that would be a good exercise if you, hopefully I've given you some ideas here of how to structure the whole thing. It is a bit messy, but how does, so the question you would want to ask to start with is, how can we use, or how use, A, B is an element of I, therefore A minus B is an element of I. How does that give us, I would start with the first one would be that 0 must be an element of identity. So if you could do that, you can show that there's a 0. I think that's you should be able to work that out. 0. Once you've got a 0, you can then show this one, the negativity. There's a negative. Once you've got a 0, you should be able to show there's a negative. Once you've got that, then you can show that the closure under addition. This is essentially closure under, this one here is closure under subtraction. But once you've got a 0 and the negative, you should be able to show this closure under under addition. So once you've got all 4 of these, you then that will show you that I, up here, I is a group. And because it's a subset of another group, it is therefore a subgroup. So I think that's just some ideas I can throw out that'll help you fashion an answer, depending on what level of strictness and completeness you want. I think I've given you the ingredients there. You may have to go back to some of my videos. If you've got any questions on this, any more on these, by all means, drop me an email or write a comment under any of my videos. And the same applies for anything in mathematics. If I can help, I will do so.